Hello, friends. Today we're moving on in Chapter 2 to talk about proportions. Actually, this is one of my very favorite things to teach, so I hope you'll enjoy learning about proportions. They're a great way to solve word problems, and this is one of the things that you'll probably use all your life as far as algebra related. So, vocab, definition of proportion. If you have your book open, fine. If not, I'll go ahead and write it out for you. A proportion is an equation, so we know there's going to be an equal sign that says two ratios, that's from 6.1, are equal. So an easy proportion that you might recognize is 1/2 is equal to 4/8. This is an equation. There's your equal sign. And it says that this ratio, 1:2, is equal to 4/8. And of course, we know that's true. Well, if there happens to be a variable in one of these four spots of your proportion, there's three different ways that you can actually solve to find what your variable is. We're going to talk about these two in 6.2, equivalent ratios and algebra. We'll talk about cross products in 6.3, the next lesson. So let's do a couple examples, and we're going to use both methods. We're going to use equivalent ratios and we're going to use algebra to solve most of the problems on this worksheet today. So using equivalent ratios, we ask ourselves, okay, how can I get from 2 to 10? I multiply times 5. Well, if I multiply the 2 times 5 to get 10, I've also got to do the same thing to the numerator. So what x will I multiply times 5 to get 20? That's the question. Well, what times 5 is 20? Of course, x is equal to 4. Let's look at another one over here using equivalent ratios. We're looking at 48 in one denominator and 12 in the other denominator. How can I go from 48 to 12? Well, I can divide by 4. But if I do it to the two denominators, I have to do the equivalent operation to the numerators. So what can I divide by 4 and get 6? What can I divide by 4 and get 6? And of course, our x has to be 24. So this is using equivalent ratios to solve these two proportions. We're going to use the exact same two ratios, but we're going to use algebra to solve them. So of course, when we're solving an equation in algebra, we box it up and we rewrite it. And now when we're solving an equation in algebra, we're asking ourselves, actually, we're saying, how can we get this variable right here alone? Well, what's he got going on? He's got a 2 divided into him. In order to get rid of the 2 that's divided into him, we have to multiply both sides by 2. Those 2's cancel, and we end up with x equaling 20 times 2 over 10 times the ghostly 1, if you want to think of 2 as 2 over 1. 10 goes into 20 twice, and 2 times 2 is 4. Now notice, this is the exact same answer we got up here when we used equivalent ratios to solve it. Same answer, different process. So I'm going to set this one up as well. I'm going to box him up because he's an equation that we're solving. I'm going to rewrite him. And I'm going to ask myself, how can I get this x alone? Once again, he's got a number divided by him. So we need to do the opposite operation, which is multiplication. Multiply both sides times 48. When we do that, the 48's cancel nicely, and x equals, and we can think single fraction bar, 6 times, and 48 I'm going to write as 12 times 4, and the 12 in the denominator. Again, your 12s will cancel, and your x equals 24, which is, thankfully, the answer we got when we did it the equivalent ratio way. So I want you to study these two ways, and we're going to actually do another example using algebra and equivalent ratios. Here's your proportion. I want you to try to use equivalent ratios and solve it. And then I want you to solve it algebraically. So you can pause the video and go back and look at my examples. Pause the video while you have your note sheet, and then come back when you're ready to watch me work it. And hopefully we'll get the same answers. Equivalent ratios. 11 to 44, how do you get there? Multiply times 4. So you ask yourself, what times 4 is equal to 56? So in other words, 4 times some number is equal to 56. If you don't know it off the top of your head, you can divide both sides by 4, and you get x is equal to 14. Using algebra, we're going to box her up. This one's a little different because the x is actually in the denominator. This is kind of weird. To solve it algebraically, we need the x up in the numerator. So the first thing we're going to do is not multiply or divide both sides by the 11, but we're actually going to multiply both sides by the x itself. And look what happens. The x's cancel, the 11 is alone, and we end up with 44x over 56. Now we need to get the x alone. He's in the numerator, so we can use the multiplicative inverse, the reciprocal, on both sides. Multiply them, and we end up with x equaling, single fraction bar, 56 times 11 over, and I'm going to write the 44 as 11 times 4. The 11's cancel, and we end up with x equaling 56 divided by 4, which is what we had over here, and that happens to be 14. So you can see we got the same answers. This one was a little bit more complicated. This guy was a little more complicated, but that's all right. We got through it. What happened to my pen? I seem to have lost my pen. Let's see if I can get him going again. All right, let's see. Here he is. I'll make a frown face for him. So I've got one more that I want you to do, this one right here, using both methods, equivalent ratios and algebra, and we'll talk about that one in class when you get back. Now the next thing and the last thing we're going to do in this note section is actually set up some proportions from word problems. And this is where I think proportions are really fun, because it's easy to see a proportional relationship, and once you set up the proportion, you're going to be able to solve your word problems pretty quickly. Be sure that the units are in the same correct place on each side of the equal sign, and I'll explain what that means as we go along. Okay, the first problem, 4 notebooks cost $4.40. How many notebooks can you buy for $6.60? So if we set up a proportion, we know we're going to have 2 ratios equal to each other. There's my shell. These are my 2 fraction bars and my equal sign. I've got $4.40 for 4 notebooks. Now, it didn't matter if I put the 440 in the numerator or in the denominator, but once I committed it to the numerator on this side of the equal sign, I've got to have it on that side. The money has got to be in the numerator on the other side. So $6.60 for how many notebooks? That's our question. So remembering that there's 3 ways to solve this, I'm just going to use equivalent ratios right now, and I'm going to say, okay, how can you get from 440 to 660? Well, I'll take my calculator, actually, and I'll divide 660 by 440. 660 divided by 440, and I get $1.50 or 1.5. So if you say, okay, I have to multiply 4.40 times 1.5 to get 660, I have to do the same multiplication to find out how many notebooks I can buy. So 4 times 1.5 is 6. So the answer is 6 notebooks. We also could have used our unit rate information that we used last time and learned last time in class, and we could have said, okay, if it's $4.40 for 4 notebooks, how much is it for 1 notebook, a unit rate? And then we would have said, okay, we divide 4 by 4 to get 1, we'd have to divide 440 by 4, and we'd get $1.10 for each notebook. And then you can multiply that times 6 and get back to your $6.60. So that's 2 different ways to work the same problem. Let's set up another one. Carl works 8 hours and earns 52 bucks. How many hours would he have to work to earn 130? Set up your shell of your proportion. It looks like this. 8 hours earns him $52. I've had hours on the top. We want to know how many hours would he have to work to earn $130, and that's the money on the bottom. So once again, you say, well, how could I get from 52 to 130? Maybe I don't know that off the top of my head. I'll take 130, I'll divide it by 52, and I get 2.5. I did it with my calculator. So if I have to multiply 52 times 2.5 to get 130, I've got to multiply the 8 times 2.5 to find out the number of hours the question asked me for. So I'll get my calculator, or maybe I'll do it by hand. That's not too difficult. 2.5 times 8. 8 times 5 is 40, carry the 4. 8 times 2 is 16, and 4 is 20, and you've got 1 decimal point to lop off. 20 hours is the answer. So these problems are really easy to set up, but the big trick is making sure that you get your units, the same units in the numerator on each side of the equal sign, and the same units in the denominator on each side of the equal sign. I have a few more. I have 3 more problems that are on your note sheet. I'd like you to work those, and then we'll talk about those in class and see what your answers come out. Feel free to use a calculator on these. You don't have to do these by hand. And I will look forward to talking to you a little bit more about this in class. Bye.